Welcome to EDU World Space.
So here we have fluid in the needle, which means that we're going to be using Pascal's principle. We'll say that the subscript P is for plunger, and then subscript N is for needle. So we can say that the pressure in the plunger equals the pressure in the needle, and we can say that the force in the plunger divided by the cross-sectional area of the plunger equals the force of the needle divided by the cross-sectional area of the needle. We can say that the force of the needle will then equal the force of the plunger times the cross-sectional area of the needle divided by the cross-sectional area of the plunger. This is going to be, we can say that F sub n is then going to equal to the force of the plunger times the radius of the needle squared divided by the radius of the plunger squared. We've set this up. Now part A asks us to solve. So F sub n would simply be equal to 2.8 newtons and then times 0.1 times 10 to the negative third meters, and then this will be divided by 0.65 times 10 to the negative second meters. And then this entire term will be squared. So we find that the force in the needle is going to be equal to 6.63 times 10 to the negative fourth newtons. So this would be our answer to part A. Now, to part B, we want to find the force in the plunger. This would be equal to the pressure in the plunger times the cross-sectional area of the plunger. This would be equal to 75 millimeters of mercury times 133 pascals for every millimeter of mercury times the cross-sectional area. So this will be 0.65 times 10 to the negative second meters squared times pi. And so the force of the plunger will be equal to 1.3 newtons. That is the end of the solution. Thank you for watching.